This is Giant Leap. I'm your host, Taylor Wilson.
And I'm Joey Lovato. Taylor, an asteroid is hurtling towards Earth.
No.
And do we have the technology to stop it? Are we prepared?
I like our chances. I like our odds, certainly better than the dinosaurs 66 million years ago. We've seen them before, and we're developing better and better tools to defend against them. So let's dive into it.
Giant Leap with Taylor Wilson.
So I have a question about space. I guess it starts on Earth, but it originated in space, and the story happened here on Earth, and that's the Tunguska event.
Oh, the Tunguska event. I love that one.
Yeah, it's something I read about a few months ago, I think, and I was like, this is something that I need to ask Taylor about. What is the Tunguska event for people who don't know?
Yeah, well, that's an interesting topic. So the Tunguska event is very mysterious. So for 100 years, people wondered what happened in the skies over Russia in 1908. And now we pretty much know what happened. It was this bolide. It was this atmospheric explosion of an incoming planetary body.
A bolide's an atmospheric explosion?
Yeah, it's basically what happens when a meteorite or either a meteor or an asteroid or a comet enters the atmosphere. And when it interacts with the atmosphere, the shock heating basically blows it apart. So think less like giant crater in the middle of the desert and more like explosion in the sky. That's what happened at Tunguska.
Okay, so there was this big explosion in the sky. Something from space entered over Russia, blew up in the sky, created this big ball of fire or like a flash, or what was it?
Yeah, I mean, it basically was like an atom bomb going off. In fact, for probably 50 years, people speculated that it was some kind of early demonstration of an atomic blast or natural version of that.
Some sort of alien atomic bomb.
Yeah, exactly. Okay. So obviously probably not, right? Like we would see technological signatures of that. But what there is technological signatures of is, this bolide, this idea of incoming impact that instead of drilling a big crater into the ground, blew up in the atmosphere. And it caused a ring of destruction that went for miles and miles and blew down trees and basically created this scarred landscape, in 1908. And then, so this is in Siberia in 1908. Okay. And then fast forward more than 100 years later, in 2013 in Chelyabinsk.
Also in Russia, right?
Also in Russia.
Russia has a thing for asteroids, apparently.
It's just a really big place. It's the biggest country in the world by landmass, so lots of probability of things impacting.
So it's not like it's more likely to be hit. The only reason it's more likely is that it's got more area, right? There's not like asteroids are more...
I don't think they hate Russia in particular. I think it's just a very big place, and so the odds of something entering over the atmosphere of Russia is more likely.
Okay.
Most planetary impacts, most objects that enter Earth's atmosphere end up over the oceans, and maybe they're picked up by a hydrophone, but for the most part, people don't even know about those. Is a
hydrophone something that detects asteroids?
Hydrophone is an underwater microphone. So we have those out there that, the government has them. There's an international organization called the Comprehensive Test Ban Treaty Organization that listens for clandestine nuclear tests. And so they have these little microphones all under the water that listen for, among other things, nuclear tests and the occasional asteroid impact.
Okay. So 2013, Chelyabinsk,
in 2013,
another one happened.
This happened again. One of these objects entered the atmosphere over Russia. It exploded midair, and along with sending pieces of the object all over the terrain, it created this massive shockwave, and it blew out people's windows, and it set off car alarms, and it actually injured some people. Now, that wasn't that big of an object, but luckily it wasn't any bigger. It would have been a much worse day. And then you go back 65 million years ago, and you start to talk about really big impacts, like the one at Chicxulub that, probably wiped out the dinosaurs.
Where's Chicxulub?
That is in the Yucatan Peninsula. And so that's a cool place. So for many years, the work of Nobel Prize-winning physicist Luis Alvarez, who worked on the Manhattan Project, and his son actually discovered this thin layer of very of iridium-rich material that had little spheres of glass and large amounts of iridium, two things that just aren't naturally found in the environment. And it was found in a thin band that we call the KT boundary, which marked essentially the delineation between dinosaurs and no dinosaurs. Deeper than the KT boundary in the geological layer, they're dinosaur fossils. And then above that KT layer, no more dinosaurs.
Got it.
And so we knew for a long time that that was, indicative of the great extinction event that wiped out the dinosaurs. But it was that telltale sign of iridium and those little tiny spheres of glass that said, hey, maybe this is the remnants of a very cataclysmic, global scale planetary impact. And as it turns out, we were able to find the location of that. Scientists were able to find the location of that, and it's right off the Yucatan Peninsula.
Okay.
And what's interesting is if you've ever been on vacation in the Yucatan, there are all these cenotes, or essentially water-filled underground caves. And if you map the location of those cenotes around the Yucatan Peninsula, they form almost a perfect semisphere of a circle. And if you map those out,
it's kind of the radius.
It's the radius of the impact.
Okay.
So if you project those back, you can actually find the center of this impact. And it was because of shock to the surrounding rock strata that you got these cenotes that formed the limestone dissolved with water. But they preferentially formed in the shocked boundary layer of the Chicxulub impact crater.
Hey, so just a note that everything we're talking about here is considered an impact event, although some only explode in the atmosphere or have such little material left to leave little to no crater on the ground, where Chicxulub, in addition to the atmospheric explosion, also had an impact with the ground, causing a massive crater, which most likely led to the extinction of the dinosaurs.
So anyway, 65 billion years ago, the dinosaurs weren't so lucky. And in 1908 and then in 2013, we were lucky. These things were not that big. But if they had been bigger, we would have been in for a much worse time, which is why, studying the future of planetary defense and how we defend ourselves against this so-called, cosmic shooting gallery is really important.
You mentioned earlier, that layer of sediment.
The KT boundary.
KT boundary. It's kind of like rings in a tree, right? Kind of the same idea, except you're going down into the dirt.
And that's what the geological record is. Just like dendrology, just like looking at tree rings, you can look down in the rock strata for signatures of the past. And, whether you're a paleontologist looking for rock fossils, fossilized bones and things like that, whether you're a geologist looking for minerals that might be useful for industrial applications, oil, gas, metals, things like this, or whether you're looking for the signs of these cataclysmic planetary events like impacts, meteor impacts, you can use the rock strata just like tree rings and date the rock strata to these different events.
All right. So we're going to move from the past and to present right now. And I'm going to talk about something that's right in front of us, actually. You have a piece of a meteorite here and then also a piece of Libyan glass. Is that right?
Yeah. So this is a meteorite. This is a nickel iron meteorite. So, some fraction of things that hit the Earth are stony meteorites.
Okay.
A very small fraction of those are a very special kind of meteorite called a carbonaceous chondrite, which are very rich in organic material. But one very common impact material that you'll find on Earth are the iron nickel meteorites.
Okay.
So that's what this is. But this is something even more special. So this is from a impact similar to the ones we've been talking about, like Chicxulub and Tunguska and Chelyabinsk. And this one happens to be from the North African desert in present-day Libya. And what happened was one of these impacts happened, one of these massive explosions happened over the Libyan desert. And it was so energetic and it was so hot that it actually fused the desert sand into glass. And we today call this Libyan desert glass. And it's pretty famous. In fact, when archaeologists unearthed King Tut's, Pharaoh Tut's tomb, there was a very famous amulet inside the tomb, and inside King Tut's amulet is actually set a piece of Libyan desert glass. So it had value, throughout the ancient world. But what it is desert sand that was fused by the immense heat of this planetary impact that happened over the, present day Libyan desert. Just kind of the power of these things to transform our natural world.
For those listening and not watching the show, the Libyan desert glass looks kind of like it looks a little bit like crystals that you'd like a
one thing
a normal crystal, right?
Yeah, one thing I like to point out is it's got a little bit of a green tint, like a Coke bottle, and that's from natural iron impurities in the glass, but it is compositionally very similar to the glass we make today. You heat up sand, silica. You melt it, and you melt it into glass, and that's what happened on a very large scale that formed Libyan desert glass.
Yeah, it looks like it's just kind of like a jagged piece of kind of tinted glass.
Yeah, looks maybe like sea glass. It has rounded edges.
Yeah, and then the meteorite is, honestly, it's like almost a stereotypical looking meteorite. Like, I don't know if you've ever seen one at like a children's museum or something.
You can pick it up. I mean, it's
heavy.
dense, right? Because that is basically equal parts iron and nickel.
Yeah.
And so, it's a very dense material. But do you know the reason that it's iron and nickel?
No.
Yeah, well, that is the final point in the journey of a star. So we can generate fusion from pretty much every element up to iron, but as soon as you hit iron, a star can no longer make energy. And so these elements that are very nuclear stable, elements like nickel and iron, are in abundance in the material that formed our solar system. And some of that material formed into planets, and those planets, rocky planets, tend to differentiate, and the iron and the nickel stratified out into the cores with a little bit on the surface. But in the material that didn't differentiate out, that didn't accrete into planets, the stuff that's floating out in the space between planets, there is an abundance of these two elements of nickel and iron.
Well, I'm sure we can get way deeper into that, and we probably will in a future episode. But let's talk now about asteroid defense, right? So this Tunguska event happened, the one over Chelyabinsk happened, obviously, and there's also the one that happened millions of years ago that made the dinosaurs go extinct. Is this something that we need to be worried about? How much warning do we have if something like one of those, catastrophic asteroids, does come and threatens life on Earth?
Well, I mean, it's a good question. The good news is the bigger the object, the more likely we are to see it. Mm-hmm. So, for example, in 2013, the Chelyabinsk impact, it was so small that we really didn't see it coming. If it came, in the wrong direction at that size, you really basically have no warning. Now, if it's a bigger object, one that's, planetary scale, planetary killer type object, we'll probably see that coming with plenty of notice. And the good news is, the earlier you see one of these things coming, the more likely you are to be able to do something about it. So, I like to use the analogy of sailing a sailboat across the ocean. A little tiny change in the trajectory across the vastness of the ocean, you could end up in totally different parts of the world. And so various tiny changes have real big modifications to where those objects end up. So the earlier we find them, if we could tug on them or maybe
push them,
or maybe, detonate some explosives or a nuclear weapon on one side of them, you can subtly change the orbit enough that it doesn't, have a high probability of impacting Earth. If we catch it at the last minute, then, that's when you start to think about things like the movie Armageddon, right?
Sure.
It gets a little bit more in the realm of science fiction, being able to do something about them.
Well, before we get to what we do about them, let's talk about how we see them and how we find them. What are we using to detect these things right now?
Yeah, well, I mean, obviously planetary protection or planetary defense is something people have thought a lot about. And so there's been decent investments in these kind of detection technologies. So there's various sky surveys that basically they set up telescopes and they look at the night sky and they look for moving objects. So asteroids, minor planets tend to be, things that you can pick up based on their motion. So different observatories, different research programs throughout the world have searches for these so-called near-Earth asteroids or near-Earth objects. NEOs as they're referred
not
to.
Not related to the movie Matrix, right?
No, not related to the Matrix.
We'll get to that another time.
That's a future topic. But many people do this, including Lincoln Lab at MIT. In fact, they named a minor planet after me. So there's
excuse me, what?
Yeah, so there's some.
How do I get a planet named after me?
There's some object out there named Taylor Wilson, and it's a minor planet. It's one of these asteroids that they found.
Do I need to be worried about Taylor Wilson floating?
They've assured me that it poses no danger to planet Earth, which is very reassuring. I would hate to have my legacy be the object that wiped out life on this planet.
Well, you might still do that, but it might not be an asteroid.
Hopefully not. I'm gonna try my best not to create any extinction level events.
Okay.
But anyway, yeah. So people are looking for these, and that's basically how they do it. They take a portion of the night sky, they look for moving objects, and then based on that movement, try to project the trajectory. And the vast majority of the objects we found, the asteroids we found, pose no threat to Earth. Their orbit doesn't even come close to intersecting at Earth. But there's a small fraction of these that does, and those are the ones we keep a close eye on. And there's probabilities. So based on their orbital period, how fast they orbit the sun and where they orbit the sun, there is a certain probability at some point in the future that some of these objects might, cross the orbit of the Earth. Now, none of these that we've discovered so far have really high probabilities, but some of them have, very low probabilities. And those are the ones we kind of keep an eye on and we continue to map. And that's important to do because, again, the best defense is knowing that they're there and being able to solve any problem that might occur long before, it becomes an immediate problem. Now, this stuff probably won't happen for hundreds of years. And by that point, I imagine that our ability to defend against them will be dramatically different than it is today. But if something happened today, if there was an object headed our way and we caught it early enough, I'm pretty convinced that we would have a chance to deflect it. And that's, what's exciting about our species. We're the first species in the history of this planet that has the ability to take our fate into our own hands and have technological tools to avert disaster. The dinosaurs didn't have that.
Oh, you're telling me the dinosaurs didn't have nukes so they could
Unfortunately, no ICBMs, so...
that we're aware of.
Well,
maybe
as far
the fossil
as we know,
record could turn up some
As far as we know,
interesting...
I've never found a fossil of a T-Rex holding, the nuclear button, but I'm willing to be convinced with enough evidence.
One day, maybe we'll find something interesting. So, okay, today, a 100 million ton asteroid is headed towards Earth. And it's directly over the lab where we're recording right now. What are you doing? You found it, Taylor. Who are you calling? The president?
I'm calling a bunch of people because I don't want to be single-handedly responsible for solving this.
But you see it, yeah.
So so obviously determining the trajectory is really important. Determining if it is a real threat is very important.
Mm-hmm.
But then the question becomes, what do you do? And so, like I said, if you know early enough, making small changes to its trajectory, that's fine. It's a difference if you catch it early enough of literally millions and millions of kilometers.
We send a rocket up with something?
Most likely.
Yeah.
So there was actually a mission called DART, which was a asteroid redirection test mission.
Oh, I remember this.
And so it was a relatively small spacecraft that impacted a relatively small asteroid. And then by monitoring the deflection or monitoring the change in the trajectory, we were able to determine that, you can actually slam an object into a rocky body like this and change its trajectory. So honestly, that's probably our best approach. Take some semi-massive spacecraft at high speeds, just kinetically impact the object and move its trajectory.
It's like if you have seen Star Wars Rogue One, there's a very cool scene where the rebels have like a hammerhead ship and they push one of the Star Destroyers into another one and they blow up because they pushed him into it.
Yeah, kind of like that.
But relating it to sci-fi,
But yeah, so that's doable. And then if, say we're a little too late for that, there's always nuclear weapons.
Okay.
And the Department of Energy, the National Nuclear Security Administration, the folks that maintain the U.S. nuclear deterrent, have a strategic relationship with NASA and the Planetary Protection Office that, basically reads that, if nuclear weapons are needed, they stand at the ready to provide that to NASA to help, avert catastrophe. Maybe the only real good use of nuclear weapons, at least the best one I can think of.
Yeah. Is this mostly an American-led program, or are there other countries that have, similar things?
Yeah, so NASA obviously has this Planetary Defense Office, but other countries contribute. So most of these missions like DART are, international collaborations. And so ESO, so the Europeans, the Indian Space Agency, the Russian Space Agency, Roscosmos, they all kind of collaborate. And that's one area that humanity has been pretty successful in maintaining collaborations in, as the world has polarized and divided itself as the Iron Curtain has raised back up. One thing that seems to be faring fairly well still are these international collaborations around space exploration. And I can think of no more unifying effort than trying to avoid, planetary scale catastrophe. So maybe that's, some little bit of hope for our future. All right. Thank you all for joining us on Giant Leap.
Yeah, thank you to our patrons for supporting us. If you would like to support the show, you can find a link to our Patreon in the description. Also, make sure to like and subscribe and ring that bell for notifications about new episodes. You can also find an audio version of the show anywhere you get podcasts.
And we're open and taking questions for us or our guests, and also potentially episode ideas. Please drop us a note.
Thank you so much for listening.
I'll see you next time.